This video is a continuation of the video I just did called 90-degree angle proves Earth is not spherical. And the idea there is that, you know, um, architectural structures are built according to this 90-degree angle. You got the beam holding up the track, and it's 90 degrees, which forms a straight line, and it doesn't work on a curve. And I go into detail about all that in that other video. I don't need to repeat myself, but after I make these videos, I think to myself, what would those globe earthers come back with to try to counter this? So I said, well, if I was one of them, I would say, well, it's such a gradual curve that this material just kind of conforms to the shape of that curve, and it just bends. And that's what one of them might say. And then I would say, well, it's not made out of rubber. The stuff would break. And they can say, well, but the curve is very slight. And I do have to admit, what I would say is that, these things have to be built a little bit flexible. And if there's like a tsunami or earthquake, it's gotta bend a little bit. It can't just crack and break. So that wouldn't prove Earth is round or flat, but that's just something they could use to counter it. So I said, okay, how can I counter them back? So again, the premise of, and if you guys have another rebuttal against this proof, I'd like to hear it. But that's the one I would come up with. So then even though these are right angles, they're not that far apart, and you could make an argument that over a long distance with a very slight curve, even though it's exactly 90 degrees, it would flex, and it would just all kind of work out. No major calculations would have to be made to make this like 89.9999999 degrees of an angle so that it curves. It would just work out. That's what I'd say. I don't know. I'd like to hear what else you guys would say. If there's more than that, or if you wouldn't say that. So then I said, well, how do I counter them? So this is how I'm going to counter that. So we're going to go to space now. You guys got to use your imagination. I know it's hard for you globe earthers because you have none, but I'll hold your hand and walk you through it like a little baby. Just feel safe and trust me. And you'll be all right. You do this for your own good. So, okay, follow along, boys and girls. So what we got here is like the Earth, and then this will be the 100-foot or 100-mile platform. Of course, it's much bigger, but it doesn't matter. We can pretend this is the 8,000-mile. We'll say this is the 8,000-mile wide platform. Same width as the supposed globe, 8,000 miles from here to here. And we will say that this platform is not built on the Earth with beams supporting it, which obviously would have to get longer as you go down to make it a true level, like a real level, not level relative to center of mass, but I'm talking about a real straight line. So how do you do that? Well, what I will say is this will be constructed in space. So we'll go to space now, and we will shoot a projectile from here to here. Beyond, we can go 25,000 miles an hour escape velocity, gravitational escape velocity. We shoot a projectile so it goes perfectly straight from here to here, an objective straight line, not subject to gravity or Earth curve. You guys following along? So then, what we do then is we suspend it with a series of helium balloons. And I know this isn't possible, but we're just like in what if land right now. Maybe one day it could be possible, but we can't do it now. That doesn't matter. But if we could do it, it's going to expose a reality breakdown. That's where I'm taking you guys now. So we construct this far enough from the Earth so gravity's not influencing any of it. And I know you could to get it, and we build the platform according to that straight line that we got from the projectile shooting from here to here to pull a straight line. And I work with some construction guys. They would pull a chalk line. There's like this thread thing in a little gadget that you kind of flick it on. You stretch it across the floor, and then you kind of pull it up and flick, and it kind of snaps down on the ground and leaves like a blue chalk line. And then they have their first straight line. So, in space we would shoot the projectile. We would shoot a rail gun projectile from here to here to pull that straight line across, and we begin construction of the perfectly straight level platform. And then so it's built far away enough from Earth, but then we bring it close to Earth. And we suspend it from the sky with a series of helium balloons, hanging from. So this thing is like hanging from cables, and we'll pretend the wind can't blow it, and we'll pretend gravity doesn't, pull it down or make it bend. It just like works. Okay, it's just perfectly straight. So then, what happens if you are walking along here? Because I got this idea because I was debating Craig, Fright the Flat Earth, and he said, well, if you built a perfectly straight, level, 100-mile long platform, you would be walking uphill, because he's saying that the real reality of up and down is based on this center of mass on the globe. So, even though this thing is straight, because it's not following the curb, you're somehow going up. But that kind of made me think, it makes sense, but it doesn't really work, because you're not going uphill. At what point are you going uphill, except that you would say this dictates my up and down. Therefore, even though this is a straight platform, I'm going uphill because all these guys are going down. They don't know they're going down, because they're just kind of standing at an angle if they're on this ball relative to me. So if we have this platform, it's hanging from the helium balloons, and you're walking on it or driving on it, you don't feel. So that's my question. What are you supposed to feel? What are you supposed to experience on there? How are you going uphill if it's flat and level? And you can see like from here to here. If you have your head, you're standing here and your head's looking straight across, you will look straight across this thing. You're not having to angle your head up, like to look up at it. But yet, if you walk from here to here and you peek over the side of the rail, are your friends standing kind of like at an angle like this, waving up at you, and you're like up? You've gone uphill relative to them, even though you're just walking. You're not walking uphill. You're walking on a flat platform. Somebody explain that one to me. How would that work? Because in theory, it could work. You could have a rigid, unbendable platform, 8,000 miles wide, or it could be 100 miles wide if you can't stretch your mind that far. And when you start running into problems, though, when you peek over at the edge and look down at guys on the globe, how does that work? What would you feel here? Is the gravity pulling you? Like, if you're like trying to stand on it like straight, is it like, is your back getting pulled down? Are you going to want to lay down on it if you're here? Going to fall down? I don't know what I just did there. You guys explain that to me, because I don't think you can.